Today, we're going to break down the incredible story of how artificial intelligence went from being a pretty clumsy opponent to an absolute strategic genius in our most beloved classic games. It's a journey from just following rules to actually outthinking the best human minds on the planet.
This quote from David Silver at DeepMind really just nails it. Games have always been the ultimate testing ground for AI. Why? Because they're this perfect little world. They have clear, simple rules, but the strategic depth is just immense. It's the perfect arena to measure a machine's intelligence right up against our own.
And wow, the progress has been just staggering. As you can see here, researchers have hit superhuman performance in a whole range of games. For checkers, they even achieved what's called perfect play. That means the AI literally plays a flawless game, making zero mistakes. It's unbeatable.
But here's where it gets really interesting. When we zoom in on one specific technique, reinforcement learning, you can see just how much of a game changer it was. As all these highlights show, RL was the key ingredient that pushed the AI to superhuman levels in so many of these games. It turned out to be an incredibly powerful approach.
So to really appreciate just how big of a revolution this was, we first have to go back in time a bit and look at the classic old-school way of building a game-playing AI. This original method was all about raw, brute force calculation, a technique we call search. It's basically about calculating as many future moves as you possibly can.
And at the very heart of this search approach was an algorithm called Minimax. The idea is to build this massive tree of all the possible future moves and countermoves, and then find the best path forward by always, and I mean always, assuming your opponent is going to make the absolute best play against you.
So think of it like this. On its turn, the AI is trying to maximize its advantage. Then, it flips its perspective and assumes the opponent is going to do everything they can to minimize that advantage on their turn. By looking ahead like this, back and forth, it can pick the safest, strongest path to victory. But here's the catch. You can't search forever. The number of possibilities just explodes. For a game like chess, you'd need more computing power than exists on Earth. So what these programs would do is look ahead just a few moves and then rely on something called an evaluation function, basically a rule book written by human experts to guess who was winning.
And the poster child for this brute force approach was, of course, IBM's Deep Blue. This thing was an absolute monster. It used specialized hardware to crunch an unbelievable 200 million chess positions every single second.
But here's the crucial part. Its strategic knowledge wasn't its own. It was programmed in. Thousands of rules were carefully tuned by human grandmasters. Now, that combination of insane processing power and human expertise was enough to beat the world champion, Garry Kasparov, but it was a victory of calculation, not true learning.
And that very limitation, the fact that the AI was stuck with what humans told it, paved the way for a totally new paradigm. The whole focus shifted from programming intelligence to creating systems that could actually discover it for themselves.
This really just lays out the massive philosophical shift. Instead of painstakingly telling a machine what a good move looks like, researchers started asking a revolutionary question. What if the machine could just figure it out for itself, simply by playing the game over and over?
And that is the magic of self-play reinforcement learning. The AI starts out knowing literally nothing, just making random moves. But by playing against itself millions and millions of times, it slowly learns which actions lead to wins. It becomes its own perfect training partner, constantly getting better and sharpening its strategy.
The program that really pioneered this whole idea was from way back in the early 90s, and it was called TD Gammon. It took this self-play concept and applied it to backgammon, and honestly, the results changed the entire field of AI.
And here's what was so profound. TD Gammon didn't just learn to play like the human masters, it got better than them. It discovered completely new strategies, things like opening moves and board positions that humans had always thought were weak. The best players in the world literally had to start learning from the machine. So this all brings us to a really interesting crossroads. We've got these two powerful ideas. So which is better, the raw number-crunching power of search or the deep strategic understanding that comes from learning?
Well, as it turns out, modern AI has found an incredibly powerful answer to that question. You don't actually have to choose.
The biggest breakthrough was realizing it wasn't an either-or situation. The absolute best AI systems today combine the strengths of both. They merge the strategic, long-term intuition that comes from learning with the precise, tactical power of search.
Okay, so here's how this modern playbook works, and it's absolutely brilliant. First, through millions of games of self-play, the AI develops a deep, strategic gut feeling about the game. Then, during a match, it uses a powerful but limited search to look at the immediate possibilities. And here's the genius part. It uses its own learned intuition to judge the outcome of that search, completely replacing those old, hand-coded rules from the human expert.
This amazing combination, this fusion of learning and search, has basically become the standard blueprint, the winning recipe for creating top-tier AI in almost every classic game out there.
So the big takeaway here is that this formula is just remarkably consistent. You find a way to represent the game board as data, then you use a reinforcement learning method, like temporal difference, which is really just a clever way of learning from the gap between what it predicted would happen and what actually happened, to build that gut feeling. Finally, you combine that learned intuition with a powerful short-term search. That is the recipe for a champion.
And that leaves us with one last, really compelling thought. Mastering games like chess and Go, where all the information is right there on the board, was a monumental achievement. But the real world isn't like that, right? It's messy, it's uncertain, there's hidden information everywhere. Applying these same powerful ideas to the complexities of the real world, that is the next great challenge for AI.